One of the skills that we need to master as 6th graders is finding the number of cubes with fractional side lengths that will fit inside a 3D figure. What this means is that we are going to be taking blocks that aren't full units but fractional units, so a third of a unit or a half of a unit, and we'll see how many of those blocks we can fit into a bigger shape. Our first question: a rectangular prism with a volume of 6 cubic units is filled with cubes with side lengths of 1/2 unit. How many 1/2 unit cubes does it take to fill the prism? It gives us already the information of the larger shape, the rectangular prism with a volume of 6 cubic units. If it's helpful, you can always draw a picture to show what that looks like. Now, a rectangular prism has rectangular sides and would look something like this. Now it tells us it asks us how many half-unit cubes does it take to fill the prism. We know the volume of the prism is 6 cubic units. It told us that here. That means the prism can be filled with 6 1 by 1 by 1 unit cubes. That's what we see here. We have a unit cube with 1 unit and 1 unit and 1 unit. So its height, length, and width are all 1 unit measurements. How many cubes with half unit side lengths can fit into a cube with 1 unit side length? In this case, we're not actually mathematically calculating how much can fit. We're going to look at this and look at what we see here and see how many we think can fit. Now, noting that this is a half, I can mark along here, cutting all of these different sides into halves. Right there, I can see there are 4 surfaces here, so that's 1 cube, 1 cube, 1 cube, and 1 cube, and then I know that it's going to repeat in the back. And they have an illustration of that a little bit further down. Oh, I realized that my screen was cut off a little bit there. So you see 1 unit height, 1 unit length, 1 unit width. Now, they show us a cube down here that does what I did in my model, where I cut the pieces according to the size of this shape. So there are 1, 2, 3, 4, and then there's 4 in the back as well. We can't see the one in the very back corner. There are 8 cubes with half side lengths in 1 cubic unit. Now this is our answer that we will fill in. Since the original rectangular prism is made up of 6 cubic units, this is the original rectangular prism, this shape back here. Now my model, my shape back here, this one is a smaller drawing than what we see here, but you can imagine that this has 6 of our cubic units, and I'm not doing that accurately, but that's just a visual model to help you understand what it's talking about here. So when we come down to our answer, it says since the original rectangular prism is made up of 6 cubic units and each cubic unit can hold 8 cubes with half side lengths, then the original rectangular prism can hold 6, that's 6 cubic units, with 8 cubes each, 8 half unit cubes each, or 48 cubes, 6 times 7. Sorry, 6 times 8, I mean to say. Now, we are not only going to be doing things visually, we are going to need to solve problems using mathematical strategies and formulas. These are the steps we are going to follow to do that. It says find the volume of your shape using normal unit cubes. Multiply the denominator of the fractional side length to the 3rd power to find out how many little fractional unit cubes fit in each normal unit cube. Multiply. We've reviewed what this means. The 3rd power means that we multiply one number by itself 3 times. Now, in our class today, we tore off the notes page so that we could include that or reference that easily while we were solving the problems. Okay. So here are our steps, and here is our first problem. It says a rectangular prism with a volume of 3 cubic units is filled with cubes with side lengths of 1/4 unit. How many 1/4 unit cubes does it take to fill the prism? Step 1. Find the volume of your shape using normal unit cubes. Our shape is a rectangular prism, and it tells us here with a volume of 3 cubic units. So 3 units cubed. I could also write 3 cubic units. This, as long as you remember the important number here, is 3. Now we're going to multiply the denominator of the fractional side length to the third power to find out how many little fractional unit cubes fit in each normal unit cube. This is my denominator, 4. Now I'm going to multiply that by itself 3 times 4 times 4 times 4. An easy way to do this is to multiply 2 of the numbers together first, and then bring down the last one. So I know 4 times 4 is 16. 16 times 4 gives me 4 times 6 is 24. 4 times 1 is 4 plus 6, 64. Okay, so now I know that in one cubic unit I can fit 64 quarter units. But I need to find out how many fit in 3 cubic units. So this is not my final answer yet. I need to take 64 and multiply that by 3. 64 times 3, that gives me 12, carry the 10. 6 times 3 gives me 18, plus 1 gives me 19. So my final answer is 192 quarter unit cubes. Let's attempt the next problem. I'm going to scoot my paper up a little bit. I did bring my steps down though so that I can continue to reference those. So again, first I need to find the volume of my normal shape, or my shape using normal unit cubes. It says a rectangular prism with a volume of 4 cubic units is filled with cubes with side lengths of 1/3 unit. How many third unit cubes does it take to fill the prism? So first thing, the volume of my shape is 4 cubic units. So again, you can write it this way, you can write it with units cubed, either is appropriate. Now second, multiply the denominator of my fractional unit, that's a third. So I'm going to multiply 3 times 3 times 3. I happen to know this is 27, but I know that 3 times 3 gives me 9, and 9 times 3 gives me 27. So that is how many third unit cubes fit into 1 cubic unit. My last step is to multiply, so I have 27 times 4. 4 times 7 gives me 28. Carry the 20, the 2 from the 20, and then 4 times 2 gives me 8, plus 2 is 10. So 108, 1/3 unit cubes. We will do one more example. The final one is the one that you can attempt on your own using the skills that we've practiced. These two problems, the one we will do and the one you will do, are more challenging because in these cases they do not give us the volume of our shape. We have to calculate the volume of our shape. It's important to remember that volume is length times width times height. So I need to find, in this problem, the length, width, and height. A rectangular prism measures 3.5 centimeters long, 2.5 centimeters wide, and 1.5 centimeters high. How many cubes with side lengths of 0.5 centimeters are needed to fill the prisms? We're given multiple choice options here. Let's look back in the problem and find length. A rectangular prism measures 3.5 centimeters long. That means length. So 3.5 centimeters. And then wide, 2.5 centimeters. And then 1.5 centimeters high. So that's my measurement for height. And that, once I multiply them, will give me my volume. However, it's quite difficult to multiply these fractions in mixed number form. So what I need to do is convert them. So if I remember, when I convert a mixed number into an improper fraction, I multiply the denominator by the whole number and then add the numerator. So let's do that over here. We'll do each one. So 3 times 2 gives me 6. And then I'm going to add 1. 6 plus 1 equals 7. So my improper fraction here is 7 halves. Now 2 halves. We'll notice a pattern here. 2 times 2 gives me 4. And then I have 4 plus 1 equals 5. So we have 5 halves. Next, for my height, I have 1 half. 1 times 2 equals 2. 2 plus 1, that one right there, equals 3. So I notice this with these fractions, because they're halves, each one took a step down. So 7, and then 5, and then 3. Each time I took away a whole number, my numerator decreased by 2. That's a side note. That's something you can notice in this. It's helpful when you're working with fractions to remember. But what is important right now is that we have converted our mixed numbers into improper fractions. So now it's easier to multiply. Our next step is a little bit tricky, because now we have to multiply 7 times 5 times 3, our numerators, and then 2 times 2 times 2, our denominators. 2 times 2 times 2 is going to be a little bit easier, so I'm going to do that first. I know 2 times 2 is 4. 4 times 2 equals 8. So my new denominator is going to be 8. Now I need to multiply 7 times 5 times 3. 7 times 5 equals 35. And then 35 times 3. That I will need to work out. I'm going to come over here to the side. 35, I'm just trying to make sure I don't go off of the screen. 3 times 5 gives us 15. We carry the 10. 3 times 3 is 9, plus 1 gives us 10. So I have 105. So 105. That was the product of 7 times 5 times 3. Okay, now that was a lot of work, but that only completed step 1. We now know that our unit, or rather the volume of our shape, is 105 centimeters, and I wrote squared, but that's not true, cubed. So next, we need to now multiply the denominator of the fractional side length to the third power to find out how many little fractional unit cubes fit in each normal unit cube. My fractional unit cubes are 1/2 centimeter. So I already actually know that 2 times 2 times 2, because I did it right here, gives me 8. So I don't actually have to repeat too much here. Now, what I do need to do, I know that 8 cubes fit into the whole unit cube, the 1 centimeter unit cube, or the 1 centimeter cube. I now need to multiply 105 by 8. Now these are whole cubes, the whole 1/2 centimeter cubes that fit into one, I'm losing my train of thought. The 8 is how many cubes, like if we look up here, if this was a centimeter and this was a 1/2 centimeter, 8 of these cubes fit into one of these. Now, what's a little bit confusing is that our volume right now is in a fraction, so it can be really confusing and hard to visualize. One of the wonderful things about this problem is that our number can be cross-canceled. So this is 8 whole cubes, so that means they are over 1. The denominator is 1. This is 105 105 centimeters cubed. We can cancel here, leaving 1 and 1, 105 centimeters. Oops, my mistake, not centimeters, but 105 1/2 centimeter blocks will fit in to our rectangular prism. Now I realize this can be very confusing because it's very abstract. We're just talking about numbers rather than actual shapes. So in this case, because we were able to cross cancel, when we multiplied, how many cubes fit into 1 unit, or in this case 1 centimeter cube, by the fractional volume of our total cube. So we have 105 cubes. Now, your goal is to attempt to solve that problem, or a similar problem, right here. We're again given fractional lengths for these different cubes. Again, fortunately, it's a ½ centimeter that we are going to be working with for the cubes, the fractional cubes that fit inside the larger cube. I want you to work on this, even if you did it in class already today, because this will help you understand what it is that we did today. This will be good practice.